Hello guys, in this video we'll be discussing index of hydrogen deficiency. Make sure to subscribe to the channel in order to get videos like this on topics of chemistry, be it physical, organic or inorganic. So let's start. So let's see the definition of the index of hydrogen deficiency. What it is, it actually shows us it gives us the measure of uh, hydrogens that are required to convert an organic compound from any state to fully saturated, important it is, fully saturated and acyclic form. And acyclic form, be it aromatic, anti-aromatic, be it saturated, unsaturated, be it fully saturated, whatever it is, we have to convert it into fully saturated acyclic form. And in that process, the number of hydrogens that will be required, that is, the number is not the IDH, it is the measure of the number, right? For example, it gives us the total measure of the number of hydrogen that will be required in the process, which you will get to know about in a few slides, right? So here's the definition: measure of hydrogen atoms required to convert an organic compound to a fully saturated acyclic form. It's important: fully saturated and acyclic form. These two forms should be maintained in the end product that we are forming, right? So let's start. What are the different methods of measurement? Uh, there are three actually. There are three methods of measurement of this uh, IHD, Index of Hydrogen Deficiency, IHD. And what are those three? The first one is, for example, let's take a compound. All right, it is having unsaturation here, right? We have to convert it into fully saturated form and cyclic form. It is already and acyclic form, right? It is already acyclic, so we do not need to worry about that. We need to worry about only the saturation, right? We have to convert it into fully saturated form. So let's write what we are given in this in the first method of measurement, right? We first write what we are given: CH3, CH2, CH, no CH, only C, fine. Then C and H, fine. This is what we have. I converted this form to this form of writing. Hope you know that, right? So now let's remove unsaturations, right? If I remove this unsaturation, I will have to add one hydrogen here and one hydrogen here, right? If I remove this unsaturation, I have to add one hydrogen here and one hydrogen here. So what we will be left with at the end will be this hydrogen bond. This bond will be broken, and this bond will be broken. Right. So how many hydrogens have we added? We have added four hydrogen. One, two, three, four. In converting this molecule to a fully saturated acyclic form. Now this is the hydrogen deficiency. Hydrogen deficiency, which is 4. But index of hydrogen deficiency is hydrogen deficiency divided by 2. Fine. In this first method, what we do, we find the hydrogen deficiency, then divided by 2, 4 by 2, that will be equal to 2. So this is the IHD, Index of Hydrogen Deficiency, for this compound, right? After this, the second method of preparation, this was the first method of preparation that was here. Let's now try to understand about the second method of preparation, right? So second method of preparation, in this method of preparation, what we do is that we use the formula. The formula is 2n plus 2 minus h divided by 2. This n is number of carbon atoms. Fine. So, and this h is number of hydrogen atoms in any given compound. Let us take this compound again. Let's try to write the formula of the given compound. What is that? That will be C4 and H6. Fine. C4H6. If you see, one, let me just use highlighter. 1, 2, 3, 4 carbons, and here we have 1, 2, 3 hydrogens. Here we have 1, 2 hydrogens. Here we have no hydrogen. Here we have 1. A total of 6 hydrogens, right? So this is the formula. Now let's use this formula to calculate the hydrogen deficiency. Fine. in this formula, what we'll be doing, we'll be using 2 into what is the number of carbons, that is 4, plus 2, fine. We'll be subtracting what is the number of H atoms, that is 6. We'll be dividing this by 2, and what is the number we get? We get 2 into 4 is 8, plus 2 is 10, minus 6 is 4, divided by 2, which will be equal to 2. Fine. This is what we have got. Again, here we have got 2, and here we have got 2. Fine. This is the second method of measurement of index of hydrogen deficiency. Now the third method is, we'll be taking up examples in a moment. Let me first make you understand the third method of finding index of hydrogen deficiency. In the third method, what we do is that we say, in the third method, the index of hydrogen deficiency for a double bond is 1. The index of hydrogen deficiency for a triple bond is 2. And the index of converting an acyclic form to acyclic form here the index of hydrogen deficiency is 1. Fine. So for example, let's take a compound. Let's take this compound, and let's try to find out the index of hydrogen deficiency, right? So what will we do? By using this formula, let me highlight it. We'll be using this method right now. Okay, so let's see how. Here we are to break this bond. We'll be saying 1 plus, we'll be breaking this bond. So what we'll be getting? We'll be getting 1 plus breaking this form to acyclic form, right? We'll be having 1. So the index of hydrogen deficiency is, sorry. So the index of hydrogen deficiency is 3. Fine. Let's put the formula over here as well. Let's try to check it out with the formula, right? So 2n plus 2 whole should be from whole should be subtracted the number of H and divided by 2. So what is the number of carbon atoms? Let's check it out. 1, 2, 3. Just a moment. 1, 2, 3, 4, 5, 6. Fine. So it will be 6 into what is the number of hydrogen atoms that we have. Just let me draw it with the yellow, right? So here we have only one hydrogen, here we have 1, here we have 1, here we have 2, here we have 2. Fine. 1, 2, 3, 4, 5, 6, 7. So we have got 7 hydrogens. Fine. 2 into 6 into 2 plus 2, and let me take it here. So 6 into 2 is 12, plus 2 is 14, minus 7. Fine. 14 minus 7 divided by 2. Fine. What will that? 7 by 2. I think we have done something wrong. Here also 1 is present, because index of hydrogen deficiency will never be in odd numbers. It will always be in even numbers. It will never be in fractions. It will be always a natural number, right? Just let me see. Here 1 H, we haven't counted that. So here we have got 8 H, not 7. So which will be 6 divided by 2, which will be 3 again. Fine. Hope you understand that. Let's also, so we have used this formula, we have used this formula. Let's try to understand now by, so you can understand how the third method will be working, which we already discussed. After this, let's take an example, and let's try to do that example for benzene. Fine. So benzene, let's first of all use first method, that is we have C6H6. Fine. We have to convert this structurally into this form, 1, 2, 3, 4, 5, and the sixth one here. Let's first see what we have. Just a minute. Let's first see what we have already got. Fine, we have got 6 carbons. Now let's draw the hydrogens that are already given on the structure. Fine. We have 6 hydrogens. Fine. These are the 6 hydrogens. Now let's convert it into fully saturated acyclic form. Acyclic form, we have done that. Now let's and this unsaturations, right? Here we will be adding 2 hydrogens. Here 1, here 1, here 1, here 1, and here 2. Fine. So what will be the net number of hydrogens that are used? That is 8. You can see that divided by 2. What will be the index of hydrogen deficiency? It will be 4. Now let us use the second method, right? Let's use the second method. In the second method, what we do, we use the formula, that is 2n plus 2 whole should be, from the whole should be subtracted h, number of hydrogen atoms, divided by 2, right? What we get is, we get 2 into 6 plus 2 divided by 2 minus also h, which is minus 6, which is something like this, which is 12 minus 6, which is 6 divided by, which is not 12, it's 2 6 are 12, 14, 14 minus 6, which is 8 divided by 2, which is equal to 4. Fine, the results are matching. Fine. Now let's use the third method. So in the conversion of, in the third method, what we do, we break the double bonds, triple bonds, and the cyclic forms, right? Let's do that. In breaking this bond, we will say IHD, that is index of hydrogen deficiency, is 1. In breaking this one, we will be saying, let us add 1 more to it. In breaking this bond, we will be adding 1, and in breaking this ring, we will be adding 1, which will be a total of 4. So here you can say index of hydrogen deficiency is 4. We have counted it in all the ways, right? One more thing that you got to understand is that for alkanes, ALKANE, yes, right, alkanes, IHD is equal to 0. Why? Because they are already, because they are for not alkanes, for not for cyclic, this won't be for cyclic alkanes, right? Cyclic alkanes, not for them. For cyclic alkanes, index of hydrogen deficiency will be 1. For alkanes only, for linear alkanes, linear chain alkanes, right, acyclic alkanes, index of hydrogen deficiency will always be 0, because they are already fully saturated and they already are in acyclic form. It should be noted, right? So that's all about index of hydrogen deficiency. Hope you understand that. Make sure to subscribe to the channel, Chemistry Crux, in order to get more videos like this. Thank you very much.